The bias variance trade-off. Let's understand these terms first. Bias is the difference between the average prediction of a model and the correct value which we are trying to predict. The model with high bias pays very little attention to the training data and it oversimplifies the model. It always leads to high error on training and test data. On the other hand, variance is the variability of the model prediction for a given data point or a value which tells us the spread of our data. The models with high variance, it pays a lot of attention to the training data and it does not generalize on the data which it hasn't seen before. As a result, such models perform very well on the training data but has very high error rates on the test data. So let's further enhance our understanding by using this bullseye diagram. So in this diagram, the center of the target is a model that perfectly predicts the correct values. As we move away from this bullseye, our predictions get worse and worse, and we can repeat the process of model building to get separate hits on the target. So we're talking about the supervised learning, and in this case, underfitting it happens when a model is unable to capture the underlying pattern of the data. These models usually have high bias and low variance. So underfitting has high bias and low variance. So this happens if when we have very less amount of data to build an accurate model, or happens when we try to build a linear model with non-linear data. Also, these kind of models are very simple to capture the complex patterns in data like linear and logistic regression. The second type is the overfitting, which happens when a model captures the noise along with the underlying pattern in data. So this happens when we train a model over a lot of model a lot over noisy data set. These models have low bias and high variance. So underfitting is high bias and low variance. Overfitting is low bias and high variance. And these models are very complex, like the decision trees, which are prone to overfitting. So what is the bias variance trade-off? So if our model is too simple and has few parameters, then it may have high bias and low variance. On the other hand, if a model has a large number of parameters, then it's going to have high variance and low bias. So we need to find the right balance without overfitting and underfitting the data. So this trade-off in complexity is why there is a trade-off between the bias and the variance, and an algorithm can't be more complex and less complex at the same time. So to build a good model, we need to find the right balance between the bias and the variance, such as it minimizes the total error. And this total error is given by this equation, which is the bias squared plus variance